it's good to be here. Good to see a lot of familiar faces and friends. I'd like to definitely thank the panelists for being here today. Also want to thank the Hsu family. Kevin and his family have been great friends and taught us quite a bit here at the Assembly. This is, as Kevin was saying, this is sort of an annual tradition, and I feel like every time we come back, we learn more and more, whether it's about regenerative medicine or wound repair. And these discussions are discussions that obviously happen one day a year in the Capitol, but the things we learn from these discussions are lessons that we keep with us throughout the year and that we really learn from. So again, I want to thank everybody for being here and for hosting, for being here in Sacramento.
Well, thank you, Mr. Speaker. Your leadership in this area has been really tremendous, and I just want to thank you for your continual support for this effort, where we all get together every year to talk about all the interesting work that's happening with regards to regenerative medicine in the state. We, of course, the state has been very committed to this area of work for a long time, most significantly through the passage of the measure a little while back on stem cell research, but there's been such really interesting work done by scientists up and down the state, and so much of it has been done in cooperation with friends from all over the world, including in China. And of course, Kevin's father is a really preeminent leader in this area who came up with some extraordinary scientific and medicinal solutions to a number of challenges. And I had the chance to see some of their facilities out in China, and of course, they've been doing some cooperative work with our folks at CERN here in Oakland. So this is a chance for us to take a look at everything that's been happening, learn a little bit about what we can do to make sure that this work remains on course. As the globe continues to face enormous medical challenges, this is another area that we need to put some investment and support into. So I want to thank you, Mr. Speaker, for your continual support for this effort, and my colleagues are here, and certainly if my colleague wants to make any comments in addition, then we'll open it up for the briefing.
I'll be very brief. I just want to thank Kevin Hsu and his family and Dr. Lilly for making this annual event. It's a great educational opportunity for legislators and for public members at large to learn about regenerative medicine and their philanthropy on regenerative medicine sciences, whether it be Caltech or Harvard or opening the biocorridor at Cal State Los Angeles. And also want to thank Speaker Rendon and Senator Ben Allen for their continual support for regenerative life services and life sciences and educating us all throughout California. They've been continuing supporting this, whether our annual event or beyond. So I'm looking forward to learning more from our friends of Harvard and Caltech.
All right, so why don't so Kevin, do you want to introduce your speakers and show from there?
Sure, actually. Well, hello everyone. I think further I will welcome everybody for coming back for the third time. This is our third year of Regenerative Medicine Briefing Forum. And the purpose for having this forum first to commemorate my father, because that was his birthday. And we always want to celebrate the life of someone who's important, who can make a difference to the world. And the reason why we're having such a forum, because we want to create a platform, as always, for the people, for the scientists, the academics, to make a communication directly with our lawmakers, to understand what is the meaning behind the science that can make such difference and impact to the societies. And because of that, that was our intention to having such kind of a briefing in a really special kind of a method. So here again, I want to thank everyone for coming. And today we have two speakers, one from the east, one from the west. Sounds like the all-star game. but we have the Caltech representative, Daniel Wagner is from Caltech, and then we have Eric Willis from Harvard. So here we go, have the speakers take on the board.
Mr. Speaker, Mr. Senator, Mr. Assembly member, thank you very much for this invitation. It's a real honor and privilege for me to be here and to present our work. As you understand, probably I come from Greece, but the last 27 years I work at Boston at Beth Israel Deaconess Medical Center, which is located in the Longwood area, very close to Harvard Medical School and other major hospitals in the area. I belong to the Department of Surgery that has a history of more than 150 years, quite a few innovations in the field of surgery, and it now includes all the current fields in surgery. One of the greatest things that happens to us is to come and work close with Roxy and C Foundation and to commemorate the memory of Dr. Rongxian Si. You all know he was a doctor trained in China out of humble origin, and he started working on the pain of people with burns, and in trying to alleviate the pain of these people and treat them, he developed new treatments, innovative treatments, and also taught us the principles of regenerative medicine. The Shu Foundation, in order to commemorate his memory, established an endowed center, the Rongxian Shu Center for Regenerative Medicine at the Beth Israel Deaconess Medical Center, and I'm the founding director. And today I'm very proud to present some of the already activities and the achievements of the center. In addition, the Shu Foundation established the Rongxian Shu Chair for Regenerative Therapeutics at Harvard Medical School. It's an endowed chair that will help one professor to keep working on this field. And again, it's a very big honor for me to be the founding person who received this endowed chair. So I would like first of all to start with this definition. As we getting into life, we all know that there are injuries, and there is always repair, but we should separate it between repair and regeneration. And this is the definition of a friend of mine and another Greek doctor leading in regenerative medicine, Dr. Yannas, who said, and I will read here, that organ regeneration is distinct from organ repair as a net point of healing process following said injury. Repair heals the interrupted continuity of tissues by contraction of wound edges and synthesis of scar tissue without restoration of normal tissues. In contrast, regeneration heals by synthesis of the missing organ mass at the original anatomical site, yielding a regenerate, not scar. Regeneration restores the normal structure and functions of the organ, repair does not. And this is what we're trying to do, to push the reparative effect towards regeneration, to develop as much as we can regenerative replacement of the injured tissue. In 1992, another prominent doctor, Dr. Kaiser, said that regenerative medicine is a new branch of medicine that we will develop to attempt the change and the course of chronic diseases, and in many instances will regenerate tired and failing organ systems. In that sense of regenerative medicine, you can see that there is quite a lot of history. It started in a sense in the 50s, where we started transplanted kidneys to patients with renal failure. After this, there was a tremendous increase in our knowledge and tremendous improvement, so we're able and routinely now to transplant livers and hearts. And some people even try to transplant faces or hands or other tissues. Nonetheless, though, although there are 500,000 transplantations a year, there is always a big problem that it's not going to be solved anytime soon, and this is that the supply of organs. is always much, much smaller than the demand. So people start looking to other sources. First of all, we look at cell therapies, and we take cells from for already ready organs, like the pancreas, and we do islet transplantation. But again, we have the problem of supply. Finally, recently, we have started working on stem cells, on the pluripotent stem cells, but still we are not close to solve the problem. In my field, I work on diabetes and its complications, with special emphasis on diabetic foot ulceration. As you all probably know, diabetes is recently a pandemic. It affects 10% of the population, not only in the United States, in China, and probably in most parts of the world. The diabetic complications are the most important, one of the most important diseases currently, like end-stage renal failure, and also eye disease, which can lead to blindness. One of the most important problems, of course, is diabetic foot ulceration, that can affect up to 20% of the diabetic population and can lead to the dreaded amputation. It's at least probably more than 70,000 per year in the United States alone, and in other countries all over the world, it's much worse. So we need to try to develop new therapeutic approaches based on regenerative medicine to address this problem, and this is what my team is trying to do. First of all, I'll show you this slide because it shows that FDA has approved 4 treatments currently for the management of foot ulceration specifically. I show you this for 3 reasons. One is that all these treatments were developed 20 or more years ago. The second thing is that in clinical trials, pivotal trials, which is the best circumstances, only 50% of patients heal their ulcers. And the third, that although this technology is quite old, the two treatments, Appligraph and Dermagraph, include cell therapies, bioengineered skin, and live cells. And actually, I was involved in one of them. So the principles of regenerative medicine have already been started being used for the management of diabetic foot ulceration. As I said, though, we need much more efficient treatments, and we are lucky that at the basic science level, we have already developed new techniques that can help us. I'll call them omics in short, and these are genomics, which they study changes in DNA, transcriptomics, they study the mRNA, which is the result of gene expression. It is the proteomics, which is they study the expression of proteins, and metabolomics, the results of metabolism of the cell. So using these techniques, it allows us now to take small part of tissues, interrogate them, and see what exactly is going on and what are the differences between patients who heal their ulcers and patients who do not heal the ulcers. And this is what we did in this slide. We took diabetic patients, took the tissue, and we took the average of all the cells there, how they work, and we tried to find some genes that are different, which means that if we manage to manipulate these genes, we may start the healing process. Of course, this is an average of all the cells, but another current technique that is very promising is the single cell technique, where what we can do is we can lyse the cells and then encapsulate each cell separately and then analyze it separately. And this is major thing because then we know what exactly is going in each cell separately, and using advanced computer techniques, we can group these cells. For example, in endothelial cells, epithelial cells, fibroblasts. And this is one group in healthy diabetic, non-diabetic subjects. Then we can do it in diabetic patients, and we see there that there's some differences in the types of cells, more inflammatory cells. And we can do it in diabetic patients with foot ulcer, and we see the differences. So first of all, Now we can see what the differences are in cells, and we know if there are differences there, probably it's where we can focus to identify patients who are not going to heal their ulcers. We can do the same anti-proteomics, the expression of proteins as well, not only the mRNA, which help us even better analyze these cells. And this is what the end results we're trying to do, and we've done in some cases. This is a number of genes that we found differences in patients who heal their ulcers compared to those who do not heal, and in animals who also heal their wounds better than animals who do not heal after specific treatment. So if you see here to the left, in red color, the genes, the patients who heal their ulcers and the animals have activated a number of genes, which means that if we can stimulate ourselves these genes via mechanisms, and we try to identify have already the mechanisms, we can improve wound healing. On the right hand, the patients who heal their ulcers had inactivated, inhibited these genes, so we can do the same. We can try to inhibit the genes and promote wound healing. Of course, cell therapy is another thing we're trying ourselves. We're looking at epidermal stem cells, and also, even more, we look at the particles that these cells are sending out, the exosomes, which may be easier to isolate and also conserve and use for treatment. And these are some very preliminary results, and I want to show you that these exosomes, they seem to improve wound healing in diabetes, so it's another therapeutic approach. Finally, we need also biomaterials, and in collaboration with Harvard University and the School of Applied Science and Engineering, we have developed biomaterials, and we try to develop something like a bandage, which when it releases the substances we have identified ourselves as improving wound healing, can improve wound healing in animals, and we're in the process now of starting a startup company to try it in humans. And using these biomaterials, again using the proteomic techniques, we can again identify the pathways that we need to affect in order to improve wound healing, and also the type of the cells that we need to stimulate. I show all this as a small example that although there's no new products the last 20 years, there's a lot of knowledge that has been accumulated, and we hope that in the next 10 or 15 years, it can lead to the development of quite a long number of new and more effective products. Of course, our endowment allow us to be involved in educational activities as well. It helps us, for example, to publish this textbook. This is the 4th edition. And also to organize seminars. We organize every other year, and you're all welcome to the Diabetic Lower Extremity Symposium at Boston, where we have the Rong Xian-Su keynote as the main event. We also organized symposia all over the world. We had the first symposium in Santorini, Greece 2 years ago, and this year we plan one more in Thailand, and also I hope that we'll see some of you there. And finally, we accept groups of doctors, especially from China, in our unit, and we train them in the management of diabetic foot ulceration, so hopefully they can develop similar centers in their country. We also go ourselves, we travel a lot. We go to China and meet with our colleagues there, and we try to establish collaborations. And this is the last time we went there with the Su Foundation, and we had the establishment of the International Society of Regenerative Medicine. So this is in short the work of our center. And I would like again one more time to thank you for the invitation to allow me to present it here. Thank you very much.
Thank you, Doctor. And I want to take a point of personal privilege to recognize a bunch of young folks from my district who are here as part of the PTA trip to Sacramento. They're up from Los Angeles area, and they're here learning about the So, all right, next, so we've actually, it's a very international group. We've got our good friend from the East Coast, originally from Greece, Dr. Wagenaar is Dutch, and ik spreek geen Nederlands. He actually did his postdoctoral work, though, here in California at UC San Diego on the medicinal leech, which I think probably gives him some good preparation for being here in the Capitol. Now he's running the neurotechnology laboratory at Caltech, and so we're honored to have him here to present a little bit about his research.
I am taking the liberty of moving this laptop so that I can, hopefully it won't die on me in the time of my presentation. I can sit here. And you don't have to choose between looking at me and the screen. Here we go. So I moved so that you don't have to choose between looking at me and looking at the screen.
Okay.
Thank you very much. It's a great privilege to be here. I thought I would use this time to introduce you to what's happening in modern neuroscience, and in particular how critical the development of novel technology is in supporting modern neuroscience experiments. So this talk consists of a couple of parts. The first will be Caltech, the second will be Neuro, and the last will be Technology Laboratory. I thought I would introduce you to Caltech just very briefly, and then we'll delve into the science. So the California Institute of Technology is a private university in Southern California. We're quite small. We have about 300 faculty, under 1,000 undergraduate students. But despite those numbers, we are actually an international powerhouse of scientific research. And to illustrate that, I will show you some other numbers. So for instance, just last year alone, Caltech faculty were issued 181 US patents. And if you translate that or calculate that to the number of faculty, that's actually one patent per professor per 20 months. So that's a pretty high rate, I would say. Another way to look at that is all the different kinds of sciences where Caltech has made groundbreaking contributions, including a couple that really have been critical for the development of modern life in California, such as seismology, and also the condensed matter physics that gave rise to the transistor, which is the absolute foundation of Silicon Valley these days. So that for just, oh yeah, and it's just not just me saying that. Caltech scientists have also been honored with any number of national and international awards of the highest rank, as you can see here. So let me say a few words about neuroscience, because of course I am a bit of an outsider in this wound healing and regenerative medicine field. So neuroscience is the study of the brain. And the brain is arguably the most complex system known to humankind. It's a fantastically complex organ. It comprises 100 billion neurons and a total of something like 100 trillion connections between those neurons. And those kind of numbers boggle the mind. So to give you a sense of how much 100 billion is, the number of neurons in your brain is very similar to the number of stars in our local galaxy. So it's truly an astronomical number. The brain, of course, is also responsible for all of our thoughts and actions. Not only does it control the muscle activation that you need to score, like Kobe Bryant here is about to do, but it also enables people to stay totally focused and do something that would be beyond what you would expect people to be able to do just by just force of mind. That's your brain. If that breaks down, that communication between the brain you end up being paralyzed, like this gentleman in the bottom image, who suffered an injury to his upper spinal cord. And Caltech scientists have worked on creating apparatus that allows to read out brain activity to such a degree that they can read out this man's intentions and use those to control a robot arm, allowing him to help himself to a drink for the first time since his injury many years ago. Lastly, the brain is also the site of many important diseases, including those that we more commonly think of as mental disorders, which of course continue to pose a very, very high burden both to the individuals affected and their families and thereby society as a whole. So brain science, neuroscience, has a huge potential for making very, very impactful improvements to the human state. Neuroscience at Caltech is a very diverse, very integrated enterprise, both looking at different scales. So Caltech neuroscientists study the brain at a very tiny scale, genes and proteins, and the neurons, cells that make up the brain, all the way up to organisms, behavior, social interactions. We are also very diverse in the organisms that we study, all the way down from tiny little simple worms, which have very, very simple nervous systems, all the way up to humans, which of course have very complex nervous systems. And to make all that research happen, developing technology, is really key, because many of the experiments that people like to do actually require technology that simply doesn't exist yet. And that's where the Neurotechnology Lab comes in. The Neurotechnology Lab supports the Caltech neuroscience community in any number of ways, as illustrated on this slide. And to give you a sense of what that means, I wanted to give you just one experiment as an example, something that's happening right now at Caltech, where development of new technology was essential. So here's the human brain. And what we would like to do is to listen in on the conversations that the neurons in your brain have with each other inside the living brain. Now, we can't do this in humans right now so well, but we can in model animals. And we are particularly interested in one area of the brain, right there, it's called the ventral striatum, and it's involved in reward processing. That means that this area of the brain is suspected to be involved in a very important phenomenon, namely teenagers being more prone to taking unnecessary risks than either younger children or adults. This brain region might hold the key to understanding that and hopefully being able then to find interventions to, keep teenagers safer. It also might play a role in addiction, which is obviously a very major health crisis at the moment in the US. So this is what it would look like if you could stick a microscope into a human brain, which of course we can't right now. What you're seeing here, those little circles, are individual neurons. The whole bright area lit up here is about the size of a human hair width. So it's very small. You clearly need a powerful microscope to be able to look at that. I want to show you a movie of what we can record in our system in a model animal right now, which unfortunately means that I have to go to the video player because my slides got mangled when here we go. So what you're seeing here is those cells being activated, and they are communicating with each other. The brightness in this movie corresponds to the activation state of all of those neurons. And we're recording here from maybe 50 cells or so, but this is rapidly advancing. We can record for more and more neurons. Okay, so you get the picture. What we can then do is, that's the wrong one, sorry, is pick out, for instance, 2 neurons here and record throughout that movie their activity level and reconstruct the conversation that they're having. So here in pink is shown what the pink circled neuron says, and in green is what the green circled neuron says. And researchers at Caltech right now are trying to figure out what that conversation means, so the language that these neurons use to communicate. Now you can imagine, because again, that neuron is 10 times smaller than a human hair, that it takes quite some instruments to record this conversation. So that's where the Neurotechnology Center comes in. Sorry, the Neurotechnology Laboratory. We built custom microscopes. So in this case, we built a custom microscope to be able to take those images in the first place. We built custom electronics. We had to build a special amplifier to amplify the tiny little signals that come from those cells. We built custom software to be able to analyze the data coming from these recordings. And we might build custom mechanical parts. Lots of the building blocks for microscopes are available commercially, but not all of them. So every once in a while we simply have to make parts. And so we have this whole mechanical engineering machine shop, including everything from 3D printers to an enormous computer-controlled mill that allows us to build the very, very precise components we need to make all of this happen. In the interest of time, I'm going to stop this conversation right here and just remind you that the overall goal is developing the tools required for the future of brain research, so that we can better understand how human brains control the human body, both in health and in disease states. I realized that I could only give you a really small glimpse of what neuroscience research is about and how technology supports that. So here are a couple of links to the neuroscience in general done at Caltech, to our neurotechnology laboratory, as well as to my own research lab. And again, thank you very much for this opportunity.
Very cool. All right. So, all right. Well, great. Well, thank you. That was wonderful and such a great example of all the incredible work happening there and why it's so important for us to keep investing. And I guess my question for you, Dr. Wagner, is can you give me an example of something that's coming up that is close to market, that's been coming out of your lab that you're particularly excited about?
So our lab is not primarily intended to bring things to market. What we want to do is support the scientists that are developing the next generation of science, which then generates probably marketable ideas. But the tools that we make are very, very highly specialized tools that we do share. We absolutely publish these results so that other people can use them. But I don't think that a microscope like the one I showed you is ever going to find a huge market because of the nature of this highly specialized science.
And where's most of your funding coming from?
Right now we are funded both by the National Institute of Health and also by the Beckman Institute. We also received a equipment grant from a foundation recently.
Okay. Let me ask you just I'm interested in asking both of you as a philosophical question. What do you, there's obviously a lot of public money that goes into investing in this work, and it's immensely important because you come up with solutions that end up helping a lot of people. Then of course you end up having private companies that take advantage of your findings and end up making sometimes a lot of money off of it. And it's partly based on the research that you've done that you're providing to the public that's publicly funded. Do you have any thoughts on how that system works and whether we've set up the system in a way that adequately reimburses the public perhaps for all the upfront investments that have been made that end up making a lot of money for private entities?
Can I say it's a very, very valid point. It's being discussed a lot. I'm mainly funded by NIA and now from DARPA. And the question is, of course, I say that we do all this research by public money, so somebody benefits for it. But if you see, they have shown that for every dollar that goes to NIH, there are so many jobs that are being created. It's about $7 in jobs. So even if the companies take advantage of it, the money comes back to society. And of course, they pay taxes, they create all these jobs, and that's probably the most powerful way for the government to get benefit. Because the other way, of course, is that they can tax the companies for all this, but then they will stifle innovation. And you should also remember that for any of this idea that becomes successful, there are 100 ideas that they do not become. And they're very helpful themselves as well, because they help us not to go there, to go the other way.
Right, right.
So I don't see any way that there can be a direct payment to the government for the research, but there is a big, big indirect research from which everybody benefits.
Right, okay.
Yeah, I would like to say something along very similar lines. Regardless of where you stand on whether companies should be able to benefit from this, I think it's very hard to think of investments that are a greater benefit to society ultimately than education and scientific research.
Sure, sure, yeah. Yeah. Let's you agree on that. Questions, Senator Chen?
Thank you, Senator. Again, thank you so much for the presentation, for both of our amazing physicians and academics. My question is, primarily, in my experience, government has some policy that impacts, especially in the area of energy. There's been a promotion of energies that reduce carbon emissions, reduce our carbon footprint. And the question is for both of you. Aside from grants, aside from participation in applications for government resources, how do you think our legislators here in Sacramento can help support some of the studies, some of the programs that you have in your own educational institutions in the areas, whether it be neuroscience or regenerative medicines? How can we support you and your endeavors for your ongoing studies?
Well, obviously, grants and peer-reviewed grants are very important. The ability of scientists to select the most promising programs is really, really wonderful. The other thing that immediately comes to mind is K-12 education and funds for the university system as a whole. We really need a continued pipeline and an improved pipeline of young people going into science who have a strong academic background so that they can actually meaningfully contribute.
And if I could add is that what is, and I always like California, is that you have all this University of California system, which is absolutely outstanding, and it is public, where the East Coast is more private. But nonetheless, in both cases, I think the government can help a lot because it's the infrastructure that needs government support. And if you have the infrastructure, especially in the education, at the education level, you have institutions that are well supplied and they have the appropriate support to have professors to tenure and all this, that sooner or later it will come back as a big reward. I think that the biggest investment is education, and what made the United States leading, we were all here, is because of the educational system, and that needs to be supported.
And if I may, another follow-up question, Senator Allen, is for someone who's the reason why we're here, and that's Mr. Kevin Hsu. Kevin, you've been a Titanic in terms of making sure that
He's not going to sink.
Not going to sink. Mr. Titanic has a phenomenal capability of having the ability to show through philanthropy, through public policy, through MEBO, some of the life-saving technology MEBO has shown to the world, not only in the United States, but all throughout the rest of the world under life-saving technology. And you've been able to do that through education, through policy, through policymakers. What are some things that you're going to be showcasing to the rest of the world in 2020 and beyond? Both Senator Allen and I and the speaker are excited to see
no matter what is the circumstance, I think partnership and collaboration are number one in priority, and also sufficiently allocating the resource in the right kind of direction through distributed and also like how we can make kind of a chemistry of a synergetic effect is also important. And one of the actually goals we have among actually in California is we're trying to find a way to create an alliance for all the universities in California to forge kind of like a bioscience valley, which is similar to the Silicon Valley in Northern California. And we have been, over the last couple of years, talking to different universities, the UC system, the Cal State system, USC, and even Caltech. And we believe that we can find a way to unify and have everyone came together to forge a kind of a alliance. So that's kind of our goal. But also in the meantime, we also have a lot of involvement on education in university in the east side. So for example, like Harvard, University of Chicago, MIT, etc. And what we see is we can also forge a similar kind of a group in the East Coast as well. And by the end of the day, we all speak in the different kind of a method, but we expressing the same kind of values, which is research science is all for the best of the humanities. So by the end of the day, I believe there will be a chance for all of us to come all together and focus on a global incident that confronting all the human beings. So I believe that will be the next solution in the future.
Your biolab and creating a biotechnology corridor over in San Gabriel Valley, the Valley of Los Angeles, seems to be a merger between young entrepreneurs and those also interested in bioscience technologies. Is that your vision, to have a crossroads between business, the sciences, STEM and STEAM technology? Is that what you envision for your biolab in San Gabriel Valley?
I want to actually have to resonate from Dr. Lewis talk about the infrastructures, because by the end of the day, I think like the young generation of leaders, I mean, they will be the new rising star, but also they need kind of an infrastructure basic that can support them to actually pursue a betterment through education or through the knowledge they gain. So by the end of the day, what we're trying to do is we're trying to create an atmosphere and an environment, or even I would say a better healthy ecology for the scientists and the academic to pursue their work and came out with turn from a mechanism into the actual application. So by the end of the day, I think is all what the government or what we have to do is we have to have a unified understanding, and in the meanwhile, how we can improve that ecology, how we can improve that environment. Then I believe like once we have the environment improved and into a better state, I believe then we will see a positive growth of all the sectors.
Yeah. Great. Yeah. Any kind of messages you'd like to, would like us to share with our colleagues in the legislature? And there's obviously a lot of competing demands on our budget, and there's always a lot of, particularly at the state level. I mean, this has traditionally been an area that's been funded by the feds, but the state has stepped in several times when the federal government, for political reasons or other reasons, have stepped back. But what sort of message do you want to leave with members of the state legislature with regards to your research?
Of course, from my point of view, I don't live here as well, but you're right that the research is mainly federally funded. But I do believe that the states play a role. And today, if you see, look at the East, China is coming up, and they have a tremendous effort there. They have developed new technologies and also tremendous support. And they train new doctors, so there will be a real competition in the future. And I think both state and federal government should take it more seriously, because for years and years now, the budget for science altogether, it will be very lucky if it is stable, if you account for the inflation. But definitely it needs a drastic increase It happened last time during the Clinton administration 25 years ago. And it's true that the projects that they're more important, but they are not very, very burning. They're not very, they don't need a direct attention, are the ones that they pay the most. So I think research and education.
The most or the worst? The most?
The most. It's the most important in the long term. It's the most important investment you can do. Although people look at the short-paying investment. But science and both at the federal and the state level, the support from the state will bring them more benefits in the long-term future.
You guys are both Europeans. What's the state of play in Europe in terms of funding in this area? How does it compare to us in the Chamber?
I say myself, I worked in England for 6 years before I came here. And if you see in England, it was the impression that money is dirty. So they had a very big science, they still have, but they don't have what the United States probably is the most advanced they have, this venture capitalism, where they can take something from the science and they bring it to production, to bring it to market. And this, the Europeans, they do not have. They try very hard now to catch up, but it's so much a mentality there different that they will take years and years if they ever catch up. On the other side, China is trying to do it. And they try to do at the state level. They have lots of money in the state and they put it in, so the competition is there.
I would say one of the really special things here is that NIH, for instance, really funds projects that are proposed by scientists rather than driven from above, and that they very well understand that scientific projects evolve over the course of their lifetime. So they're not particularly worried if what you end up doing is not quite what you thought you would end up doing. And that gives scientists the freedom to do amazing things. So back to your earlier question, California is an absolutely amazing place for science. There are so many top-level universities here, far more than you would expect given the size of this state. And I think, yes, that has been helped tremendously by federal money, but it has certainly helped California become the economic powerhouse that it is now too. And as federal money is obviously outside of our control, I think that the California State Assembly and Senate can really help by ensuring that funding for science in this state continues. Because I think it is essential for the continued well-being of California and Californians.
Do you think? Another question, just about the, how are your colleagues view regenerative medicine? I mean, is it? Do you think it's kind of making its? Do you think it's staking out its place in the world of medical research in a way that's much stronger now than maybe 5 years ago? I mean, do you think are you seeing a shift in attitudes amongst the academics in this area?
I can speak from the Boston point of view. Because Larry Summers, the previous Harvard president, chairman, he came and he gave a lecture once and said that nobody in Boston realized and can understand how the Silicon Valley left Boston and came to California. But biotechnology is the new Silicon Valley, and we intended to keep it in Boston. It's true that they try to develop all the resources, but I believe biotechnology is the new Silicon Valley, and regenerative medicine biotechnology more or less is the same thing. And we have just scratched the surface. So much we can learn from there, and also at this point we have a lot of basic knowledge as a bottleneck to bring it to the bedside, to the patient. But even the government, they paid money, sooner or later will come. But whoever controls biotechnology, it will be probably the most powerful nation on earth. And that's why I believe China as well is investing so much money in biotech.
Do you have any comment? I mean, just because there are some. It seems like there are some people, at least in the past, in some of the more traditional medical research avenues that have been skeptical.
Well, my colleagues are neuroscientists by and large,
Yeah.
so I'm not so close to that field. My impression is that gene therapy, for instance, initially was oversold a little bit. It turned out that things were much more complicated than we at first thought. But I do think that we are getting to an inflection point, and that the future of this sort of thinking is very bright. But again, I'm a little bit farther away from that field than my colleague.
Well, we appreciate this a great deal. This has become a wonderful annual tradition. I'll say that the International Society of Regenerative Medicine and Wound Repair actually was founded here.
Yes.
Here in the state capitol over downstairs. I remember a couple of years ago at the first of these briefings. And so we really appreciate this opportunity to kind of do a check-in every year on some of the work that's been happening. And there's just extraordinary professors. And you're the latest of several that we've gotten a chance to see and hear from, which is really fantastic. So I hope everyone will join us. We're going to have a reception down over in room 317, which is actually, good luck finding it. But you're all scientists, so you know you should be able to. It'll be a real IQ test to find room 317. But it's a beautiful room, and it'll give us a chance to have a more informal opportunity to chat a little bit about the latest and all the work that's been happening. But I really do appreciate this annual tradition, and I think we're all kind of looking at seeing what we're going to do moving forward as a state. I don't know if you have any closing comments, Kevin? No. Okay. All right. Well, we appreciate you a great deal, and thank you to my colleague and Senator Chen. Thank you to our speaker for being here as well, and for all the guests who are here. I know we have some folks who come in from China and elsewhere. I appreciate you being here, and let's all go get a little bite to eat. Thank you, everybody. Room 317.
I'm Eric Wang from the National Xu Foundation. I'm the Secretary General for the foundation. So we are so happy to have everybody here today to join us in the third year of the Regenerative Medicine Day at state capitol. So we are so honored to have all of you. So first, we would like to welcome definitely our good friend and supporter, Mr. Philip Chen, to give our greetings. Oh, thank you.
Good afternoon. It's such a pleasure for me to be here today. I want to thank Kevin Hsu and Dr. Lili for having this annual event that introduces regenerative technology here at the state capitol. And I also want to thank our good friend, Mr. Senator Ben Allen, for being kind of the spearhead in this leadership event. And he knows better than anyone else that here in the Assembly and here in the Senate, most of us are generalists. And we go from here to there in terms of different policy issues. So to have an annual event in which we can really sit down, have our experts from Caltech, our experts from Harvard, talk about life sciences and how it impacts the state of California and beyond is critically important. This is not only for the people part of the panel, the people in the audience, but it goes throughout the entire state capitol community. It is via live feed, and the information that we share today will be recorded, and it will be shared with our 80 assembly members, our 40 senators, and also the governor himself. So I'm very grateful for this opportunity. I want to thank MEVO. I want to thank Dr. Lili and Kevin Hsu for time and time again making sure that there is a crossroads between the business community, the fields of higher education, public policy, and politics to make sure that important regenerative life sciences is on the forefront of medical technology. It's a great pleasure to be part of this conference. I look forward to many, many more. But it doesn't stop here. Once we leave the California State Capitol, this type of education continues on. Research continues on. The life-saving technology continues on for our county hospital institutions and also in the private sector. So I'm very, very grateful to have the opportunity to be here today. With speaker, Anthony Brendan, that was here earlier on. So with that, I know that Kevin and Dr. Lilly will be saying a few words, as well as Senator Ben Allen. And with that, would I like to introduce the next guest, which will be Mr. Kevin Shue. Thank you so much.
So again, thanks for Phil for the introduction. I would say like this is our third year, and every year we keep our hardest to keep the traditions going, because we're knowing that like more and more times we're doing, we're kind of creating this kind of a clear path how we can find a way to communicate among lawmakers, business communities, and academic world. And I believe like we are all speaking the same kind of language, and we are all united because we all believe in the human values. And I believe like no matter what kind of professions or what kind of background you have, you always kind of find the similarities among each others based on the things we care. And we all know that my father was a burn doctor. He spent his entire life on burns and treating others. What we're trying to do here is not only in the field of regenerative medicine, but we're trying to regenerating the world. We're trying to regenerating the people who are suffering, who are actually having this kind of damaging their mentalities, physical, anyway, and all kind of ways. So by the end of the day, we're knowing that by understanding human value as the ultimate values, we can find bridging among each others. And in the same time, actually, I want to take this opportunity to actually introduce a non-for-profit that we're actually launching a couple of weeks ago. It's called California Fight Against Coronavirus, because we know that in the recent outbreak of the coronavirus around the world, it will soon become a global instance that all mankind will confront. And we, as a Californian, we all know the importance of responsibility, social responsibilities. And for this foundation, is not a foundation that we focus on donation or contribution, but we'll focus on communication and creating path. By saying that, we mean the foundation are how to serve individuals who want to help others around the globe that are suffering the aftermath of the coronavirus. So in creating a communication windows among government, among non-for-profit sectors for them to find the right kind of people who they can outreach, and also the right kind of people that can receive help among the coronavirus incidents. So hereby I just want to, again, thanks everyone for coming, and we're all knowing that there are multiple ways to show social responsibilities, no matter what kind of a field or what kind of a state of art we have. But by the end of the day, we're all knowing that we're living, and we're trying best for the betterment of others. Thanks.
Good job. Okay. Thank you, Philip.
Senator Allen.
Yes.
You've all probably heard a little too much from me already, but I'm a politician, so I can't ever give up the opportunity to speak. I am proud to be a part of this effort. I know I speak for my colleagues and Philip Chen. We were both together in Beijing and saw the incredible work of Yibo there, and it really was inspiring. I gotta say, you're very fortunate to have a leader like Kevin. I think brings a great deal of modesty, compassion, intelligence. He's also fully bicultural. I think he's able to navigate a lot of two very different worlds, and he does so with real grace and class and sophistication. And so I'm a big fan of his, and it's part of why we wanted to make sure that there was an opportunity to highlight the incredible work that he and the company and the center have been able to fund all over the world. And it turns out, this guy can pull in professors from the top universities of the world every year. So now this year we have Harvard and Caltech represented. Next year we're going to have University of Chicago and Oxford, right? So it just speaks to the breadth and scope of the investment and the relationships and the kind of relentless passion for trying to make the world a better place. And I think the latest initiative associated with the coronavirus, which of course is on everybody's mind and certainly very frightening. I've talked to my friend who's the head of the city of Sacramento China office, and we've been talking about the impact that it's had on the economy. No one has to be reminded, the stock market took a huge dive today because of news of this topic. So, it speaks highly of you, Kevin, that you're really trying to put your energy into trying to create a source for funding help. I mean, I know it's been difficult, and there have actually been some bad actors who've entered into this space and have taken advantage of people. And so it's going to be good to have a single place where people can donate and that can actually make a difference in helping to stem the tide of this awful virus. So, Dr. Lili as well. I mean, I just want to. I consider me a friend and someone who wants to, and an advocate, someone who wants to help you grow your very important mission. And I just want to thank the professors for coming. I want to thank everybody for being here, and we want to make sure that this continues to be a tradition that will inform and allow California's involvement in this area to continue to grow. So I appreciate you being here a great deal. Thank you on behalf of my colleagues in the State Senate.
So again, thank you everybody for coming. And we have a beautiful afternoon. So we have about 30 minutes more here. So enjoy your drink, enjoy your food here. So we look forward very much to next year. So hopefully we can see you again next year. Thank you so much.
That'd be great. I'd love to. Yeah. Hi, Professor. Great to meet you. Thank you. Yeah, likewise. All right. Bye, guys. Thank you. Thank you. We're going to fix grease. Political system. All
So we would like to have a final.
Just saying the same thing. Yeah. Why don't you group photo everybody?
Over here? And on that. Oh, sorry.
We're doing a quick group photo, my friend.
Yeah. Let's do 2 rows. Tall people in the back, short people in the front. We'll rearrange you just so everybody's face is visible.
这个还在排吗？
没关系，你问一下。
Yeah, I'm gonna start pointing here in a minute. You guys, I need you. All right. Gentlemen, we have some folks over here. You guys are tall. Great. Yeah. Yeah, if you're in the second row, just be off the shoulder of the person in front of you. That way. I'm less worried about the signage rather than the people. Absolutely. Okay. Fantastic. All right.
Those are great. Okay.
All right.
Clear one more time. 1, 2, 3. All right.
Cool.
Thank you.
Thank you.
Thank you. Now we need to grab the lunch box.